Okay, this is called the Poisson distribution, and oh, by the way, the textbook's pretty good on these, and it's got some good examples for you to work through too. So if you're having trouble with the probability aspects, do go to the textbook. The textbook's actually quite useful from now on in the course. It wasn't that good for the earlier parts, but it is good for these later parts. Okay, now the Poisson distribution was named after Mr. Poisson, which is the French name for fish, but it has nothing to do with fish, it was just his name. Okay, so it's often used to model a number of times a particular event happens in a given time interval. It also can be the number of times a certain faults happen within a certain length of fabric, or there are things like that. It's to do with a rate. So when you're talking about something per something, that generally means it's a Poisson distribution. Now, here's a hint. In the non-proctored quiz, the questions come in a certain order. So you'll always know there'll be a binomial one, and then there'll be a Poisson one, and then there'll be a normal one, and then there'll be an inverse normal one. But I've been a little bit tricky this year, and in the proctored quiz, they aren't going to be in order. So you'll need to be able to tell whether it's binomial, Poisson, normal, or inverse normal. And the way you can tell it's a Poisson is because it talks about a rate. It will be something per something. And it may well be that it says is modelled by a Poisson distribution, because we don't want to be too tricky here. Okay, so here, on average, customers arrive at a burger drive-through at a rate of 40 per hour. And that's known as mu, this little letter here. It's a sort of a squiggly. You've probably seen that there's some cars called mu these days. And so it's 40 per hour. Now, there is some confusion as to rates and means and so on in Excel and somewhere else, and I can't quite remember what I came up with last year, but what I know is that the notes are correct because I worked it all out last year. Some books use a different terminology, some of them use lambda instead, and sometimes lambda is 1 over mu, and sometimes what they talk about as mu is actually 1 over what we talk about as mu. But this is correct for what we're doing. And what we want to be able to do is use Excel, and so this is correct for using Excel. Okay, so on average, the customers arrive at a burger drive-through at the rate of 40 per hour. We've got this mu. What is the probability that fewer than 35 customers will arrive in the next hour? So we want to know the probability that X is less than 35. So we use Excel by going equals Poisson. Poisson, and then open brackets. And we've only got 3 arguments this time. Arguments are these little things here. And so X is the number of events that we're interested in, so it's 35. And the mean is 40. And cumulative, so we're saying probability that X is less than 35. So yeah, we want to, all of the ones, what's the probability that one person or 2 or 3, cars turns up? So it is cumulative, so we put true, not with a stutter. And we go, so we've got our answer here is 0.2424 whatever. However, that isn't correct. That one there gives us X is less than or equal to 35, but we want the probability that X is less than 35. We don't want to know the probability that 35 cars turns up. We want to know fewer than 35. And the reason we might want to do this is because we may have a certain capacity or whatever. And there are 2 ways we can fix it. You can either make it that it's the probability that X is less than or equal to 34, which, because it's chunky, you can't have 34 and a half cars. So if something is less than 35, then it has to be less than or equal to 34. So what you would do then is you just change this here from a 35 to a 34 and work it out. And that will be the correct answer. And that's the way I'd do it. Or you can just find the one with 35, less than or equal to 35, and then subtract the probability of 35. And either way, the answer is 0.194, is it? Yes. Okay, I might make this a little bit bigger. So there it is. Okay, so, and I made up this chart last year, but I'm not sure it really works that well, but I've left it in there in case some people like it.